All right, so section 3.1, quadratic functions. So let me ask you this, what is the name of the graph of a quadratic? What is the name of a graph of a quadratic? Starts with a P.
Parabola.
Parabola. All right, what's the most basic quadratic you can think of? The equation.
X squared.
X squared. So we'll just start with the most basic quadratic, x squared. And we all know this graph touches the origin at 0, 0. It goes like this, okay? So this point on the quadratic, other than it's being at the origin, is called the what? What is that point called on a parabola?
Axis of symmetry.
And it's not the axis of symmetry. Axis of symmetry, we'll see, is a line that goes through the parabola. Starts with a V. Vertex. That's the vertex. Vertex is that point where it kind of the middle of the parabola, right? It's where you got your two sides, okay? So that's the vertex. And now on this one, of course, it's at 0, 0. Now there's a line that you don't see that runs right through here. Nobody draws that, but it's called the axis of symmetry. And it's just like the imaginary line that it's just telling you, hey, parabolas are symmetric. The left side and the right side are folds or mirror images of each other. And what that means is, like, for instance, if I go over 2 units left and 2 units right, I should be at the same height. And you can figure that out by plugging in. So if I do negative 2 squared or 2 squared, what do I get each time? And what would the same thing be? 4. It's 4. So basically points at the same height, we say are the same distance from the axis of symmetry. Now, the equation for this axis of symmetry would be x equals to 0, because it's a vertical line through x is 0. All right. Now, a couple of other questions we might get on this graph here. And was everybody, this isn't too much, like everybody, you have this shape memorized, right? So I didn't want to go through and plot all the points. I figured we knew this. If I ask you, where is it increasing and where is it decreasing? Now, when we do these, we do it just like we would do domain. You give the x's and put it in interval notation. So can you give me the interval for where the graph is increasing, and can you give me the interval for where the graph is decreasing? And the way we do things is it's always a left to right. So from left to right, where's the graph going up and where's the graph going down? And put it in interval notation. See if you can do that real quick. Okay. Sydney, you ready? You want to give it a go? Where do you think it? Okay. Well, look. So you see that there's 2 parts to the parabola, right? Mm-hmm. What do you think this one's doing? Well, like, how would you explain this? Would you say you're going up or going down from here to here? Going down. So that's decreasing. All right. What would you say you're doing on this side? Increasing. You just give the x's, so we can see it's from 0 forever to the right. So what interval would that be? 0 to infinity. Now, will you ever reach infinity? No, I hope not. So you put a parenthesis. And since 0 is kind of the changeover, I put a parenthesis there. I don't put a bracket. Because it's it changes here. Because it goes decreasing to increasing. So that's why I put a parenthesis. We'll find out in math lab if I'm wrong, right? Because if I tell you that and you put it in there, and once a bracket, I think that's how you're supposed to do it. Decreasing then, so again, this section it's going up forever this way, but on this interval from left to right, it's going down. So negative infinity to, because you give the x's, don't give the y's. Way out here is negative infinity. Yeah, negative infinity to 0. You put parentheses. Okay? So, right now, I'm gonna give you some transformations of this. Transformations means movement of this basic parabola. And I wanna be able to do, where's the vertex? What's the axis of symmetry? Where is it increasing? Where is it decreasing? I don't think I do. Just check again. Increasing means, so this is what increasing means, okay? Increasing means the graph is going up from left to right. Okay, so that would be like this. Okay, could be like that. It could also be like this if the parabola is going down. That's what increasing looks like. Decreasing means graph is going down from left to right. And it could go like this, it could be like this, it's going down. I'm trying to think of the different parts of a parabola. Okay, does that make sense? Okay, all right. So example one. So on all of these, here's what we're gonna do. We're gonna do four things. We're gonna graph, we're gonna find the vertex, we're gonna do AOS. What's AOS short for? Okay. And we're gonna do increasing, and we're gonna do decreasing. Those are the things that basically describe your parabola, okay? All right, so x minus 3 quantity squared plus 1. So do you remember what transformations we do when we have something on the inside here and a number on the outside? So what does the inside tell you to do? Move it left to right. So, but this one was a little tricky. The inside, if it's minus, you move to the right. That's right. So this means move right 3. If it's a plus on the inside, you move left. And we can look at why that is in just a second. And then the number on the outside, you move where? Up. That's right, up 1. So all you gotta do is take that graph and move it right 3 and up 1. Now here's what I would do. I would just move this point and then redraw it. So the point I would move is just move the vertex and then redraw the picture, okay? So try this, go ahead and move the graph. Just do it real quick. You only really need to plot that one point and then make your little sketch there, and then we'll look at the answers. And we'll list all the answers out here to the right. Okay, so where's the vertex going to move to? Right 3, up 1. So I'll put that first. And then I just draw my parabola. I'm just going to sketch it like that. Now it still opens up. When is the parabola going to open down? Do you remember?
Negative out front.
When there's a negative in front. And we did some basic transformations earlier in chapter 1. So that's what we're building off of. All right. So now, all right, so there we go. So we've got the graph. We can see what our vertex is. Our vertex is 3, 1. We just write it as a coordinate like that. Everybody see how we got that? Okay. Axis of symmetry would go where? Yes, that's very good. It's whatever your x is. So it goes right through there like that. So your axis of symmetry is x equals 3. And then can you figure out where is it increasing and where is it decreasing? Well, that 3 helps because that's your border. And you know it's gonna go forever, so it's always something to infinity and negative infinity to something. You just gotta figure those out. All right? Anybody wanna give the increasing? All right, Hank can give increasing, Lee can give decreasing. Hank, what'd you get for increasing?
3 comma infinity.
And I'm gonna put parentheses on both of them because it never reaches infinity, and this is a changeover. Where it changes from one to the other. All right, what about decreasing?
Negative infinity.
Okay, very good. All right. When do I move left? When will we move left?
Plus.
When there's a plus on the inside. When do we move down?
Negative.
Negative. But again, we touched on that in chapter 1, so I wasn't gonna reteach that. We're just gonna kind of review it in our head. And a negative in front, remember, I call it rotisserie chicken, flips it about the x-axis, okay? All right, so, and I always do my flips first. So if I have a flip, I'll do that part first. So we'll do the same answers. So here's all of our answers here, along with our graph. So we'll do another problem. So let's say we've got same example 1, negative x plus 2 quantity squared plus 3. Okay, so we know the negative in front is going to cause it to flip across the x and open down. Okay. So I would graph it first and then find my vertex, find my axis of symmetry, and see where it's increasing and decreasing. This is like I'm thinking of the starting graph. What happens?
Oh, I was about to say.
All right, so let's go through the graph first. So a negative always flips my graph about the x. So I know the negative is going to make it do this. Then the x plus 2 there makes it move which way? Left 2. And then the plus 3 on the end, that moves up. Okay? And we're here. Now, if we want to find x-intercepts, we're going to do that more in the next section, like where are these x-intercepts at? That's the next, that's 3, 2. So we're going to worry about that later. If we wanted to find the y-intercept, we could. If we just plug a 0 in for x and we solved, it would give us the y. I don't think that they're going to ask that, but if they do, that's all we would do. Just, if you want, where does it cross the y, you plug a 0 in for x. Now, I think we would see it's negative 1. If we plug a 0 in, that's, what's 2 squared?
4.
Negative in front. Negative 4 plus 3 is, so it should be like right there. But I don't, we're going to do more of that in the next section. All I want you to be able to do are those 4 things right now. So now I can label my vertex. My vertex is what? Yeah, now, there's another name you could give this, like a more of a descriptive name. So just like we did this one here, and they're both called the vertex, but there's another name. So this is the blank point on the graph. This is the blank point on the graph. Yeah, so the other word we could use is when the graph opens up, that's the minimum. That's the lowest point on the graph. And when the parabola opens down, that's the maximum. So you may also see or hear that terminology, well, not here, but you may also see that terminology, okay? All right. So vertex is -2, 3. Now I want to look for a shortcut. So look at our two that we've done and look at our equation. Start thinking about, is there a shortcut to doing the vertex, right? Is there an easy way to get that? So think about that. Axis of symmetry is what? X is equal to -2, right? Runs right through the middle of the vertex. Increasing on what interval? So now it's flipped.
Negative infinity,
Yeah.
-2.
So it's going up from left to right, from -infinity to -2. Remember, you always give the x's, okay? You don't give y's on increasing and decreasing. And then decreasing would be what?
-2 infinity.
2. Okay. All right. So far, so good. Ready for one more? We'll do one more. All right. Remember what we've got, the answers, and then I want to see if you can give me a shortcut for finding the vertex, so that maybe you could just give me the vertex straight from the picture. So we'll call this one part C. Now, sometimes you could have a multiplier in front, like a -2. The 2 is just going to make it a bit skinnier. It's not going to really change much there. X minus 5 squared minus 1. Okay, so if there's a number in front, if it just stretches the graph a little bit, so you don't need to worry about that. The location doesn't change. Okay, so this is just a stretch. So any time that number in front is bigger than 1, it will stretch it. If it's like a half or a third, it'll make it a little bit wider. But all you need to worry about is there's still a negative, so what does that do? And then where does this move and where does this move? Okay, so the 2 just may make it a little skinnier, but that's it. Okay, so see if you can give the 4 answers, the graph and the other answers. See if you can do that real quick.
So wants to graph it.
Yeah, takes you 2 seconds. Okay. Let's go through all the movements. The -2 in front does what? Opens which way?
Down.
Down. -5 on the inside does what?
Move to the right.
Right, 5. Okay, -1 on the end moves it where?
Down.
Okay. So the vertex, you should have got it at 5, -1, and it's opening down, and I'll make it a little bit skinnier like that. Give me else, that's what that is. All right, question?
I thought since it was a negative out in front, it goes to that and it makes it.
No, do distribute it.
So then
Do
it
not,
makes
no, it does not do it. Don't do that. Don't put it inside the parentheses. Leave that alone. We're gonna type them in on our calculator in a second. If you've got Desmos on your phone, you can type it in on Desmos and you'll see. Okay. All right. Okay. So remember, minus on the inside, you move right. Plus on the inside, you move left. Minus on the outside, we move down. Okay. So what am I missing? What's next? What else? So we got our vertex is at 5, -1. What else could I do?
Axis of symmetry.
Yeah, what's the axis of symmetry? X is 5. Increasing on what interval?
Negative infinity, 5,
Decreasing on what interval?
5, yeah.
Okay. All right, very good. So go ahead and get your calculators out and type this in and see if this is the picture you get. So just go to Y1 and type this in. And then I want you to think about, is there a shortcut for finding the vertex? Like, can you just write the vertex down by looking? Look for a pattern in all 3 problems.
So we don't have to do anything with the stretch.
It just makes it a little skinnier. So yeah, you'll see that the graph is a little bit skinnier. The 2 makes it skinnier, but we're just worried about these. So it doesn't change that it's still at 5, negative 1.
I have a question, how come this sign is like not negative?
All right, so do you agree that to the right of this dashed line, it's decreasing, correct?
Yeah.
All right, when you do increasing and decreasing, you give the x's. All right, so 5 is where it starts. Way out here is positive infinity. All right, that's the answer to your question. 5 to infinity, it decreases.
And the other side is
Again, I give the x's. So on this side is where it's decreasing. There's the x is 5, what x is way out here? You give x's, not y's. Your eyes shouldn't go down like that and say negative infinity. It's negative infinity because of this. You gotta use x values when you do increasing and decreasing, not y's. Does that make sense? Okay. You understand her question? Because when she's seeing this go down, she's thinking, well, that's negative infinity. So she's asking, why don't we put negative infinity? Because you only give the x's, like you would do domain, okay? That's a common mistake that students will make. Okay, did you guys type this in on your calculator in Y1? Everybody has it in there? Okay, can anybody give me a shortcut for finding the vertex? Like, what can you look at and know the vertex, yeah?
So, if you look at, you just switch the number inside the parentheses, so it would be positive 5,
Yeah.
and then you just tag it in that last number.
That's right. So whatever this is, switch the sign, and whatever this is, that's the y part, and that's it. So, just hypothetically, if I gave you x plus 7 squared minus 2, what would the vertex be?
Negative 7 on the negative.
Very good. Okay. All right, we'll write that down in just a second. Okay. All right. Here's what I want you to do, though. I just want you to graph this on your calculator, and I guess you can save this in Y1, put this one in Y2. Ready? So here's what I want you to put. Negative 2x squared plus 20x minus 51. I want you to graph that in your calculator. Leave the other one in there in Y1, graph this one in Y2, and tell me what you see. You agree? Yes, it is. I did that on purpose. Okay, so we're gonna let that marinate for a second, okay? We'll come back to this. So let's put what you said down in like a little formula, all right? So a little formula for what Leah said. We say that this is the vertex form of a parabola. If we do y equals a times x minus h squared plus k, if I make like a little formula, the a is the number in front. So if a is greater than 0, how is the parabola going to open? If it's positive, yes. It opens how? Up. And if a is less than 0, how does it, like a negative number, how does it open? Down, okay? And what is the vertex? So now we can make a little formula. Leah said if it's minus, then you should write it how? Positive. So what would the vertex be if I'm using the h and the k?
H comma K.
H comma k, that's right. So the opposite there and whatever that number is on the end. Okay. Now we'll talk about this. So there's two ways that we write a quadratic. One is in this form. The other way is what we call general form, which I just did. Ax squared plus bx plus c, where it's expanded like this. So the first thing is, do I have you sold that this is the same graph?
Yes.
Yeah. That's what I was hoping to do, right? You type this one in, you type this one in, oh, I get the same picture, so they're equivalent. These are both equal. The problem is, if I just give you this, what do you not see? What is hard to see in this when it's written like this? What can you not tell? That's exactly right. You can't see the vertex. At least this -2 and that -2 are the same. So this at least tells you what? What do you at least know about the parabola? Down. That you know. So first thing I want to show you is, how did I go from here to here? Because that's like pretty awesome, that, right? I mean, how did I know that? I must be a Jedi Master or something, which I am, but it's really fairly easy. Here's all I did. I just squared this out. I just foiled this. So I want to show you real quick how I can go from vertex form to general form. Just to show you that why they're equal, okay? So all we're going to do, if we take part C up there and just actually square it, actually multiply this out, do the FOIL, distribute the -2, you should get this. So just do your FOIL method real quick. What's FOIL stand for?
First, outside, inside, line.
Yeah, first, outer, inner, last. So do your FOIL, multiply by -2, subtract 1, see if you get this. Let's just take 2 seconds. Well, take a minute. Almost done. We'll just talk about what we do if it's in this general form, like how do we graph it. We'll talk about that. And that will pretty much finish it. Okay, so let's look at the work. Make sure that you've done the math properly. So, why would I want to do this? I wouldn't, because I like this form better. Why do I like this form better? You can see the vertex, you can see it opens down. But let's just go through the math to show you that they're both the same. So if I do FOIL method, first, x times x, we get what? So that's where your x squared comes from. X times -5 is -5x. -5 times x. -5 times -5. Plus 25, and then don't forget a -1. Now these two -5x's add up to what? -10. So we got x squared minus 10x plus 25 minus 1. Then I'm going to distribute the -2, and let's see what we get. So we get minus 2x squared plus 20x minus 50 minus 1, and there's where, right? Because when I distribute a -2, that turns into a positive, that turns into a -50, and don't forget the -1. So all I did was I just did it in my head real quick to come up with this, just to show you. All right, but here's the problem. If I just give you this, it's kind of hard to, the question is, we still want to be able to do graph, we want to be able to do the vertex, we want to be able to do the axis of symmetry, we want to be able to do increasing and decreasing. So what's hard about this, sorry, this turns into a 51, right? What's tough about this is we can't see we don't know the what? The vertex. Vertex we don't know. We do know, because of the -2, that it opens like that. If I told you the vertex was 5, -1, would you be able to graph it? If I said, hey, the vertex of this is 5, -1, you would go to 5, -1 and draw a parabola that opens down. The question is, how do you know what the vertex is? Well, here's the shortcut. All right. So we can find the vertex when it's in here. There's a little formula we use called the Vertex Formula. So when you're in general form like this, and you don't know the vertex, you can always get it by doing -b over 2a. If you do -b over 2a, that will tell you the x part of the vertex. Then plug x in to get the y. Okay, so we're going to do that together. So we already know the answer. We already know that the vertex is 5, -1, but we're going to just use this little formula to see that we get what the vertex should be. So to get the vertex, which of these numbers is b? The 20. The middle is the 20. So it says do -b over 2a. So -20 over 2a. What number is a? -2. All right. And do the little math on that. See what you get. See what answer you get there. So that's b 2a. That's multiplication there. So what's -20 over -4? Is that what we should have got? Yeah. All right. Then what does this mean? Plug x in to get y. What does that mean? So we don't know the y part of the vertex, right? So how do I get a y anytime I want to get the y? And yeah, do you know what your x part is? You got to take your 5 and plug it in. And when you plug it in, you should get -1. So let's see. So I'm going to take the 5 and plug it in. So -2 times 5 squared plus 20 times 5 minus 51. I'm going to work that out. You can use your calculator. I'm going to work that out and see what I get. If you see, you will get -1. What's 5 squared? 25 times -2. This should have been -50. What's 20 times 5? You don't need a calculator, silly goose. Come on. What's 20 times 5? 100. So look, -50 and -51 is how much? -50 and -51 is how much? -101. -101 and 100? -1. Okay? Look, I'm not going to be, like for you guys, multiplication when you have a 0, do not go to your calculator. Because Noah is in 4th grade. And Noah has explained to me how to multiply when you have a 0. Noah's my youngest son. He says, Dad, did I tell you the story about this? He was just telling me, he says, Dad, I learned something new today, how to multiply when you have a 0. He says, all I do is I don't worry about the 0. I just multiply those numbers. So 5 times 2 is what? 10. Then at the end, I put the 0 back on. He's in 4th grade. I know you can do it. So don't go to your calculator. Okay, we're gonna do another one. Now I'm gonna give you one that you don't know it. It's in this general form. Now notice, this A here and this A are the same. So the number in front of x squared tells you if it opens up or down. Okay? All right. So we're still on example 1. We're still going to do all of those. So we're still going to do graph, vertex, axis of symmetry. I would probably find the vertex first. So let's say we have 3x squared minus 6x plus 1. So, notice it's in general form. So the first thing let's get the vertex. Don't forget it's negative b over 2a to get the x, and then plug in to get your y. Now, let me ask you this. Is it gonna open up or down? Up. And that 3 would actually make it a little skinnier, but don't worry, just do your best there. And then you should be able to graph it and do all the increasing, decreasing. So see if you can do that real quick. Do your seating chart again, because we've got new students. Gotta put it. And guys, you gotta are you comfortable there? Are you okay? I was gonna say you could move up, but I know you usually sit in the back. Are you okay there? You're good. You guys all been here. Sonara, you're good back there? Not too far away? You're close to the door so you can get out of here fast, right? Okay, so it's just memorizing this little negative b over 2a, right? So let's see, and it's real simple, a, b, and c. So negative b would turn into what? Positive 6. So do negative 6 over 2a, and a is 3. Well, we end up getting 6 over 6, which is 1. Then I still need the y part of the vertex. Yeah, I plug a 1 in. So I like to just do my work right here. So if I plug a 1 in, I'd get 3 minus 6 plus 1, which is what? Negative 2. You should have got 1, negative 2. Because if you don't get the vertex, then the graph is going to be wrong. So everybody would see where I got these answers. Because I take a 1 and plug it in for x. Well, if I plug a 1 in for x, it doesn't change anything. So that's my vertex. So now if I have the vertex, should it be easy to graph?
Yes.
Yes. So let's see, vertex 1, negative 2. You just plot the point. Does it open up or down? How do I know it opens up? The first term always tells you, the a. Remember, if a is positive, it opens up. So there's that. All right. What's the axis of symmetry? X equals 1. There's that. And again, Sonari, remember when you do increasing and decreasing, so you think of it, I like to do it like this. Just, I know that way out there is negative infinity, way out here is infinity, and there's my 1. And now I can see my 2 intervals like that. Okay? So increasing on what interval? Anyone? No? 1 to infinity. And decreasing on what interval? Yeah, there you go. So does everybody see why the axis of symmetry is helpful? Because it shows us where it switches from one to the other. And this point right here is also called a minimum. Okay. You think that's enough? We can get going in this section 3.1? Okay. What we'll do is we'll see what questions you have on Wednesday, but that for the most part gets us going, okay? So I'm gonna go ahead and stop this.